Using an Anova, we are able to test for differences between scores on different groups. In this SPSS tutorial, I'm going to teach you how to do an Anova using income level and role within the school. We're going to look at difference in income level across the three groups: teachers, administrators, and other teaching staff. So what we're going to do to start is go up to our favorite button, the Analyze button, go ahead and click, and we're going to, just like with the t-test, go down to Compare Means. If you go over there, see we have all of the three t-tests that we talked about in the last session, and we're going to go down to one-way Anova. Go ahead and click on your Anova right now. Oops. You can see that I already have run a couple of these tests for your slides, but when you click on your one-way Anova, you'll see that you have an opportunity to put in your dependent variables and the factor. The factor is really going to be your grouping variable. What is the variable that represents the groups that you want to compare? So like I said, we were going to look at respondents' income. So we're going to click on respondents' income, move it over to the dependent list, and then we were going to look at current position in your organization. That's going to be the factor. Now again, we have three groups within that variable. You have teachers, you have administrators, and we have other staff. So what we're going to do with this Anova is compare those three groups, the average income across those three groups, to determine if we see any differences. So the appropriate test statistic using an Anova is when you want to compare average dependent variable scores across different groups. Are we ready? Okay, let's go ahead and click OK. And it's a very simple output, just like you saw on the slides. The Anova output, again, our dependent variables respondent income in US dollars. We have our between group and within group sum of squares, our degrees of freedom, the mean square, and then we get to our test statistic over here. What we see is we have an F statistic of 1.467. Generally, when you would report out, you're going to report out to the hundredths place in the decimal, so you would really only report that. You would round that up and say 1.47. Your significance level, 0.249. What does that tell us? You're right. This is a non-significant test. So since 0.249 is greater than 0.05, what we can conclude is that we failed to reject our null hypothesis, that there are differences across those three groups. Now, that's good. That's good to know. When we go back and look at this case, we realize we're dealing with a small sample. So if we got this kind of result and we expected something different, it might be worth exploring a little bit further to understand whether or not this is a valid conclusion, or if this is a conclusion that might be non-generalizable beyond this particular group of individuals. If you have any more questions about the Anova, I recommend you take a look at the readings. The readings are going to actually explore some additional components here, and I'm going to actually click off of this. Well, actually, I'll just go back and explain to you what would happen if we found this to be if we found this to be a significant result. There are post hoc tests which would give us results about what the differences are between those groups if we found a significant result. In order to do that, if you click on the post hoc, so we went back to Analyze, Compare Means, and to one-way Anova. Get back to our box. If we click on our post hoc test, you can see the two that I talked about, your Bonferroni and your Tukey test. Those two tests are probably going to be the most useful for you in terms of comparing significant differences between the groups. What that will do is say, of those three groups, who's different? Since this is not a significance test, we're not going to get a result. I'll click on Continue, but we're going to get an error. And then go ahead and click OK. Oh, it actually ran. Very cool. So you can see what the multiple comparisons do. And again, you get your significance levels here. So teacher to administrator, teacher to other staff, administrator to teacher, other staff. It's much like your correlation matrix where you'll see different numbers here, but ultimately that's how you would tell whether or not those groups were significant between each other.